Good afternoon. We're pretty pleased to be here with you at the conference. I'm going to take you through a few things today. One is just some general introduction to the security space and where we play. Also talk about our fit with Redis and how we think we do a pretty good job of complementing a great solution with our security. So that's what we're going to go through today. So first off, Zetaset is an enterprise software company, and where we got our start was actually creating a hardened layer, if you will, or a wrapper for the Hadoop open source. As some of you may know, or all you know, there are pieces of Hadoop that still survived, but the market itself didn't really take off as much as people thought in terms of the hype and the valuations and so forth. Being an enterprise software company, we actually make money when people deploy software, not evaluate software or evaluate through pro services. We're not that type of company. So we figured out there were some things that we really learned over on the Hadoop side, especially within that high performance parallel processing environment in terms of security. And within Hadoop, security was really pretty non-existent. And we found out in developing our technology that we did a very good job of distributed encryption, high performance encryption. And so it's very well suited for distributed databases, for distributed data servers, distributed storage, cloud, and so forth, because a lot of the older solutions or legacy solutions are centralized. And being centralized, they're expensive, they're basically based on appliances, and doing policy checks on the encryption, which is a normal process that happens while you're encrypting and decrypting data, you were making round trips back to a centralized policy server. In our case, it's all in software, and we distribute it in a way that you can centrally define policy, but the policy then is pushed out to the data nodes. So it's much more efficient and very high performance in terms of how we encrypt. It's also very transparent, so instead of working specifically on an HDFS file system, which we developed with the Hadoop piece of it, we now have a very high-performance software-based encryption solution that runs on virtually any database. That's why we're partnering with Redis. And we also have extended it to object-based as well, which is another alternate store for the Redis solution, which we'll get to in some of the use cases. And since it's a software-based approach, it's inherently much less expensive. However, people have encryption in place today, and they might be using a hardware security module or somebody else's key manager, and ours are compliant in a way that we can intermix with any of those components. So you can use our software solution, which has its own HSM, which we call a soft HSM, a virtual key manager, or you can interact with any of these other components that exist to have a full solution. So that's really the basis of where we are today. It's been a pretty significant pivot for the company. But we're just starting to materialize very good relationships and partnerships and reach customers with this new distributed encryption solution. So this is what's happening out there in terms of the security environment. And this is really a pretty useful site. This is called informationisbeautiful.net. And what it allows you to do is see up-to-date breaches that are happening out there in the world. Some as large as 30,000 records that are affected. And so it's a pretty interesting site because you can actually sort. It's an interactive site where you can look at verticals, different industries, different companies. You can look at essentially, was it an internal issue in terms of an insider that caused the breach? Was it a breakdown in protocol? Was it a configuration error? Was it an outside hack? So it's a very, very useful site. There's another research company that puts out some pretty good data called Ponymon. And Ponymon put out their last report in July of 2016. But what they accounted for was the average cost of a data breach is $4 million. And it's about $258 per record on average. And they also predict that within the next 24 months, which would be the next 12 months now, since the issuing of the report, that 24%, upward to 24 to 26%, new breaches will occur that are more than 10,000 records. So the actual problem is not getting smaller and it's not going away. So if you look at a typical security model, there's layers of security. And you might be familiar with some of these technologies, but if you look at, firewalls is really the first physical barrier between the public net and a private network. You look at another layer beyond that, which is intrusion detection, that looks for breakdown in protocols, policy, any anomalies, as they call it, that might have instigated or started a breach. Intrusion protection systems go one step forward because on the IDS data, they actually create countermeasures that actually deal with the breach and have corrective measures that are put in place. And then you have the identification access management systems that very exactly identify who has access to what in terms of authentication. So all these layers are there. The problem is these have been hacked and will continue to be hacked. I mean, people find ways in. Also, people sitting inside the interior of the network actually have access to that data as well. So really the only way to ensure that the data is really locked down is to encrypt it. And that's what we're talking about today, and that's what we've been focused on. People have been a little bit scared of encryption because they think it's complex. They think they need to be a security expert in terms of being able to set policy on the encryption processes, and they don't think the performance is there. And so they weigh the performance of their applications against security, and performance wins. But our solution really debunks a lot of that perception. So just to give you a real simple view of encryption. So, crypto comes from cryptos, which is with a K, which is Latin for hidden or secret. And what it allows you to do is shield from an adversary or a third party. The originator of the data is the only person that can see it. The adversary or the third party cannot, right? And so that's really what it's about. It really picked up steam in World War II when we were decrypting or trying to break the encryption of a lot of the movements of the German military. But it found itself from there really deeply seated in federal and now into a broader set of enterprises. And really the crux of it, obviously you have an algorithm that you're encrypting with, you have plain text that's fed in and then it's stored in encrypted text, right, or ciphertext as it's called. But essentially the real crux of this model are the keys. And so protecting the keys, or what we call the crypto assets, is really what you use to decrypt and encrypt the data. And once you have those, essentially you can act as the originator of the data and decrypt the data. So a lot of effort is put around protecting those private keys, as they're called, and making sure that those don't fall in the wrong hands. And essentially we do a lot of different administration. It's not as simple as creating keys and certificates and storing them or retrieving them. We do a lot of maintenance in terms of rotation of keys, wrapping of keys, being able to actually change keys without having to re-encrypt data and things like that are behind the scenes. The net effect to the user is that you essentially can't see the text unless you have the key to unlock the text. I had a discussion with somebody last night about masking, data masking. Well, data masking only masks the data when it's presented at the application layer. But then when it's stored back in the store, it's stored in the clear. So you're still exposing the data when it's stored. That's the problem. I had another person talk to me and say, well, you don't need encryption. All you have to do is destroy the data, right? Well, that's, if you want to use the data again, that's not a very good solution. But also, we do authenticated encryption that allows you to essentially detect that somebody's changed the data. So if you think about it, without even bothering with getting the keys or finding the credentials to unlock the data, you just write over it or delete it or change it. We can detect that with our authenticated encryption. So there are new evolving threats that even the cipher technology, the encryption technology is evolving to meet these new threats as well. But essentially this is the crux of what we do as a company at Zetaset. So this is a pretty useful slide here, and there are a lot of different reasons people want to encrypt data. The biggest one, though, is compliance. And when we work with partners, it's typically a healthcare or a financial service or federal type deal. In healthcare, you got HIPAA. In businesses, you have SOX. You have essentially GLBA. You also have, PCI DSS on the consumer side. So all of these are different standards of compliance in terms of really what will happen to a company if they lose control of sensitive data. And the cost, I think you've seen Target, you've seen Anthem Blue Cross, Home Depot. There's been quite a few breaches where I've lost my credit card data and had to go redo everything again as well. But really the cost of those things are not just compliance, it's reputational costs. CEOs get fired. It's the transactional cost of having to go correct all those records that were stolen. So the stakes are pretty high if you have a regulatory compliance infringement. And so that's what a lot of people look at in terms of if it's going to be laying around on disk anywhere, if it's going to be sitting in flash, if I'm going to be putting it up in the cloud, I need to encrypt it. So we have a very good fit with Redis. I mean, Redis is about very high-speed, real-time applications and access of data. Also, Redis is about ease of deployment, high throughput, low latency, but also least amount of resources required to essentially grow your database. And then if you look at another piece here, high availability. So being able to actually get to your data when you need to get to your data is the big thing. The one fallback, and the reason that's created an opportunity for a partnership with Redis, is that this was really engineered not so much with a security focus. It was engineered for trusted users in trusted environments. And that's a scope thing. That's not an oversight on Redis' part. That's just where they focused. And really, they're partnering for the security aspect. But where we bring to the puzzle is essentially making sure that the people that are seeing the data are truly trusted, and that this thing isn't directly touching the internet without any security in place, and nobody can get to the IPsec layer or to the socket layer, the Unix socket layer, and extract the data. So here's where we come in, and amazingly our list looks a lot like Redis list, but it's actually not a marketing slide. We really focused on transparency, ease of deployment, being able to deploy our encryption very easily, being able to also maintain in these distributed environments very low latency and very little impact to performance. And also, we've actually patented our own high availability scheme, which we started with on the distributed side with the Hadoop market that we were first in. But it allows us to actually have a highly available key manager. If you remember what I talked about earlier, if you want to decrypt the data, you have to have access to the keys and also authorize access to the keys. So being able to have a highly available, easy to deploy, software only, very low cost system compared to appliance approaches, very high performance in distributed environments, that's why we're a very good match for Redis and why we're developing our relationship. So if we talk about performance, really, I talked about it earlier, but having everything in a unified solution and controlling the crypto part of it, and we basically are able to control policy, enforce policy, and push policy out to the data nodes. We have very, very low impact in terms of data at rest. And we've tested this with generic databases, which are an average read and write cycle, but we actually do better than 3% depending on certain vendors that we're working with, and we're doing that validation effort with Redis right now. We have validated our performance numbers with Clustrix and with Greenplum, where we also deployed with Greenplum out in the marketplace as well. And the bigger thing is on the data in motion side, where we're actually locking down anything moving between any of the data nodes, between any consoles, between anywhere that the data is traversing, even on route to cloud, we're only impacting data in motion by 7%. So, and that's actually quite a bit better. In fact, in a test with Greenplum, we were about a quarter of the impact of the performance and data in motion to a vendor Vormetric. So I think that the focus we've had in re-engineering this technology within a distributed environment has really paid off. When we get into some of our authenticated encryption schemes, we have high performance there as well because we use Galois counter mode, which allows us to do a lot of the processing in a very performance-centric manner. And we have much better results in terms of our authenticated encryption as well. So here's the specific use case. Excuse me. And if you look at it, really where we're helping Redis is anywhere they park the data outside of in-memory, that's where we protect it. So whether they're parking it in flash, whether it's in ephemeral or persistent storage, Basically, they also push it to elastic block storage and S3 object base in AWS. We can encrypt it there as well. And we can really encrypt it anywhere that they're parking it, for want of a better technical term. On the AWS side, there's a big data encrypt product we have, which actually does the elastic block storage encryption as well as the encryption within persistent storage, whether it's HDD or flash. But we also, on the object base, have another product, and you can get these data sheets at our booth, which is called Xcrypt. And Xcrypt is a very granular, object granular type product, bucket by bucket, object by object, where you can actually encrypt the data en route to AWS. So any way Redis want to store it out of memory, away from the in-memory processing, ephemeral or persistent, we can support the encryption on-site or in the cloud. And if you look at the cloud, here's the issue with the cloud. The issue with the cloud, most people say, well, why are you selling an AWS encryption product when AWS does encryption as well? Here's the issue. The issue is that most of those crypto processes are happening within a VM. So not only the crypto processes, but as I mentioned before, the crypto assets, namely the keys, are exposed within the VM. And essentially those can be breached. That's one problem. The second problem is eventual encryption. If you're encrypting it from the premise side before you put it into the cloud, then you know it's encrypted. Whereas if you pass it to Amazon and say encrypt this data, there's no assurance when it is encrypted. And you might say that's paranoid. That doesn't fly from a compliance standpoint. So people that have hard industry compliances that we talked about, they need to make sure the data is encrypted. Not only that, they have to make sure that the crypto assets themselves are protected as well. So doing it client side before it's passed into the cloud is really allowing you to control the keys, control the processes, and essentially control all of the data in its non-encrypted and encrypted state from the premise side, and still leverage the scale, still leverage the economies of the cloud. So whether it's private cloud, public cloud, hybrid, doesn't much matter. We can encrypt it anywhere within that path. Okay. So just to sum up, what we've done in our software solution, what Redis has done in their database software solution is really a pretty good fit. The layers of security, we have a long time security architect, and he just lives by one credo. If you really want to make sure it's locked down, encrypt it. Because otherwise, it can be breached. Now, you can argue that people can get access to keys and breach the data as well, sure. But if you have very good policy in terms of how you're maintaining, managing your keys, rotating your keys, and actually have controls over who has access to the keys, you can actually manage that much more directly. If you look at GLBA that I just talked about, GLBA is about processes and how you contain the data and how you train people to contain the data. So this is really a means by which you can really lock things down. But it's not very costly. It's software. It's really easy to deploy. You don't have to be an encryption expert or a security admin to deploy this stuff. It's very easy to deploy and set policy, and it screams. So it's very high performance, and it presents no burden to Redis or any of the value propositions that they're creating in their marketplace. So that's basically the sum up. We're pretty excited. We're thankful that we could be a sponsor here at the show, and also had the opportunity to tell you a little bit about Zetaset, but that's what we have. So are there any questions?
Thank you. A couple questions in the context of the overhead, right? The 3% number. So that was the overhead in what type of architecture?
Right. So what we do is there's a benchmark. We've done TerraSort benchmarks. We've done other benchmarks, but essentially we're looking for the incremental burden. So right. There's burden that gets introduced all along the way in terms of how people lay out their network or arrange their servers or what type of servers they're using. But what we do is we set a benchmark, and then we say what's the increased overhead on top of that. That's where the 3% is.
Per node, can you give us an idea what the amount of memory that this is taking up in terms of
Yeah.
any CPU cycles that we get an idea of?
It's minuscule. It's, really where you take up space is how many keys do you want to have? And really the keys can be as big as a database, whatever database you want to create. That's one piece. Then there's obviously the stored data. But in terms of what we're creating, there's a very small amount of metadata that runs on top of the crypto processes. That doesn't take much room at all, right? So I would think the only other burden is if you want a highly available key manager, the way we do it is we do it through an election process. So you actually have to have 3 nodes dedicated for redundancy in your key management system. But those are really the only pieces that we burden.
In other types of applications where you may have some end devices that are the source of your data, right? That's coming up into Redis, so IoT type of applications.
Very good.
So if you're looking at an edge device, can you put the encryption down at the source? And if so, what is the size of that application and storage of it?
Yeah, there's some challenges in running this level of encryption at the actual end device, which you're probably well aware of. But there's something called an IoT gateway. And so we think we can protect from the IoT gateway in, and there's plenty of horsepower there to run our type of encryption.
Okay, so that was my next question. So you're sitting in the gateway then in that particular architecture?
We're looking at applying it. I wouldn't say we're sitting there yet, but we're looking at that's where we would apply our encryption technology. We've looked at that market, and really clearly we have a play in the core data centers where the data ends up, clearly. But if you really want to extend your reach in terms of protecting the data in transit, it's really out to the IoT gateway that we're looking at.
Have you looked at anything in the peer-to-peer network type of architectures?
We have not as yet, no.
Okay.
Yeah.
Thank you.
Thanks a lot, Jim. That was a very good presentation. We loved it.
Oh, great. Thank you. Thanks, everyone.